Hi, my name is Simeon Kakpovi,
And my name is Greg Schloemer.
and today we're going to talk to you about KC7, a game that we built to help students, professionals, and anyone get experience practicing their cybersecurity analysis skills using realistic data. A big problem when you're trying to break into the cybersecurity field, like Greg and I did, is that you often need data to practice on to get those skills. But the only place you can really get that data, since it's so sensitive, is on the job, right? But that creates a deadly cycle where you need the skills to get the job, but you can't get the job without the skills. And so we built, this training platform that built on simulated data that you can practice on without actually needing a job. And today we're going to really walk you through how you can access the KC7 data and how you can get started with it.
Yeah, thanks, Simeon. So one of the goals of this video, whether you're a player looking to participate in KC7 or someone who wants to host an event using KC7, we'll talk more about that later. But we want to really show you the entire experience from start to finish. And so that KC7 experience really starts here on our website at kc7cyber.com. So here you'll see an overview of KC7. You'll learn a little bit about how it works and how we are able to actually model the realistic data that real cybersecurity analysts are using on the job. The important part for someone who's playing the game is going to be the training packet here. So we can scroll down to the bottom, click on view training and download the packet, or click getting started and go straight to that section. So once we've downloaded the packet, we'll go here. And this KC7 training packet is really a player's best friend. It's going to contain an overview of all the skills, all the tools, and the techniques that you'll need to play the game and be successful. We really made sure to build the packet in a way that it works for everyone. So if you're a beginner, maybe a high school student, a college student who's looking to get their start in cybersecurity, the packet contains an overview of those foundational skills that maybe you haven't developed yet, but you're looking to practice through KC7. If you're a working professional, maybe even a cybersecurity veteran, and you just want to sharpen your skills, you can skip through those sections that maybe you already feel comfortable with and get straight to the stuff that's most relevant to you. So in this training packet, we're going to get started and jump right into the tool here. So the entire KC7 experience takes place in a tool called Azure Data Explorer, or ADX. The great thing about ADX is that it is used by security teams all over the world for security analysis. And so when you play KC7, you're not just in some, simulation demo world, you're actually using the real tools of the job, and you get practice using those tools. So the packet's going to direct us to go to ADX right out of the gate. That's at dataexplorer.azure.com. And when you first browse to Azure Data Explorer, you'll be asked to sign in with your Microsoft account. Once you've done that, the next step is to connect to the KC7 data cluster. And the packet also contains instructions for that. So we'll be given what's called a connection URI, and that'll be our key for getting access to the data.
And
So
I'll
from
jump in really quickly here, Greg.
Sure.
Sometimes if you're hosting an event, you might be given a connection string, but other times you may not actually have access to an existing cluster. And so we have some instructions about how you can actually self-host that data on our GitHub page. So if you go to kc7cyber.com and click to on GitHub, you can go straight to our GitHub page. And there's a link in the README section about how you can load this data onto your own cluster. So if you scroll down, you can check out the instructions for setting up the data in your free cluster. We have instructions as well as a YouTube video that will walk you step by step through how you can download that data on your cruise to a free cluster. It doesn't cost you any money, so you can get started on your own without needing a URI string from anybody else. If you're hosting an event, you can also create your own cluster in Azure, and then you can use the same instructions to load that data so you can share it with other people.
Yeah, great call. I mean, thanks for that. So for those folks looking to host data in their own ADX cluster, you'll also find instructions for that process here on our GitHub wiki. All right. So jumping back over to ADX, like Simeon said, your connection, your connection URI may vary. If you're at an event, Your version of the packet may contain a different connection URI, or your host may give you a different connection URI. If you're working on this at home independently, you'll want to use your free cluster, like Simeon said earlier. But for this, we're going to connect to this mystictraining.eastus. A little autocorrect bug there. mystictraining.eastus, we'll click add. And now we have access to our cluster. So the packet further explains this concept of a cluster versus a database versus a table in ADX. We're going to skip it for time's sake in this demo, but we see here one database called security logs and then 8 tables. So each of these tables represents a different source of security log data that we are collecting within our company. To build on that point, at the start of the packet here, we really lay out the foundation for this experience. So players of KC7 are going to be employees at a company. We do have different versions of the data. We'll talk more about that later, but for this particular packet, players are employees at a company named Involve Labs. So this is a biotech startup. It's your job as a player to analyze log data from Involve Labs and then protect the company from cyber attackers. And so these 8 tables are those security logs collected by Involve Labs. Simeon, do you want to talk a little bit more about what else we have here in the packet and where we go next?
Exactly. So as Greg was saying, we have 8 different tables, and the 8 different tables essentially have different information that show you different pieces of the puzzle about what's going on, right? So we have an active intrusion against Involved Lab going, right? There's, one or more bad guys or cyber threat actors that are targeting the company in different ways using different infrastructure. So some may be sending phishing emails, some may be trying to send malware, capture credentials, steal files, ransom files, encrypt files. And that story is stored all in the data, right? It's just up to the user to connect the different pieces using, the information available in the different clusters. And in real life, as cybersecurity analysts, right, this is what we do. That is a critical analysis skill, right? Learning how to take data, ask the right questions, and then put the dots together so you can tell the story about exactly what happened. So in the guide that we have, right, we teach you primarily how to use KQL, Kusto query language, to manipulate data. So we're not getting into cybersecurity yet. We're just showing you at a basic in a basic scenario, how do you actually manipulate data? Kusto is like a Microsoft's version of SQL that runs runs in our Kusto and ADX products. It's fairly simple to learn. And so we have, very in-depth tutorial that shows you how you answer various questions or how you find various things in the data using KQL. So we walk you to that part, and then we jump to the next section, which is actually, okay, you know how to query data in a basic level. Well, how do you apply that to a cybersecurity scenario? And so we give you an example of a bad guy, right? A tipper of a bad guy doing something bad in your data, right? So in this case, the tipper is one domain that the adversary owns. And then we ask you some pointed questions to help you figure out how to take one indicator, right, or one piece of information inside the data and use that to build an entire campaign. So in this scenario, if you scroll down a little bit, Greg, right, we have a tweet about someone finding a malicious domain. The scenario here is a phishing email leading to data exfiltration, right? So someone sent a phishing email, and at the end of the day, they want to steal data from users' inboxes. And all of that, again, is encapsulated in the data, right? But as a new user, since you don't necessarily know how to do that yet, we help you out by asking you guided questions that will walk you through what questions you should be asking to get to that stage. And if you scroll down, Greg, right, we have an example of, some key questions, right? That will walk you step by step through, what should you be asking next? What should you be finding? What other things should you be looking for in the data that aren't quite there? And the hope is that as you get more comfortable with this in the future, you get comfortable yourself knowing what questions to ask without us having to do that, right? In the future, we should be able to give you one piece of information, and you should, try to start figuring out where you should be looking next and what kind of analytical questions should be asking to help you build that full story on the actor. And once you get comfortable doing that, as we walk you through it, in many cases, we'll give you a third scenario with an entirely new adversary inside the same data, where you can use that hint to find malicious activity, except the questions may not be as guided. You may have to work a little bit harder to build out the full story.
Exactly. And one thing I want to highlight here, as we're looking at these questions, some of these may seem difficult. If you're watching this and you aren't a cybersecurity analyst, maybe you're wondering, how would you solve these? But that's where the training packet comes in. We really guide players step by step through the process, like Simeon said, of applying those analytical questions, knowing where to look in the data to answer a question, knowing how to take a question and convert that into the KQL syntax that you need to look in the right place. So start to finish, it's really a constant learning process, and all along the way, you're building additional skills and learning something new and fun.
So, Greg, you want to try out one example and see what a user experience might be like?
Yeah, exactly. Let's do it. So instead of answering these questions we see in the training packet, we're gonna take a slightly different approach and pivot on a different indicator. So here we're starting with immune.tech, and then we have a series of questions about that particular domain. But for this exercise, we're going to start with a different domain that we received from a partner tip. And this domain is mobile.io. So let's see what we can find about this domain in our data. So in the KQL 101 section, players learn the best thing to do when you're looking at a table is to always start with a take 10. And what this does is it allows us to look at the first 10 rows in that table and just see what's here, right? So if we look at the email table, you could guess just from the name of the table, this is probably going to contain data about emails that have been sent and received by employees at our company. So when we look at the table, we'll see all the different columns. We can see what kind of information is here. And immediately, if I know I have a domain, mobile.io, I can look, we know it's an email-based threat, perhaps, so I can look for the columns that contain a domain. Well, we have a sender and a recipient that do have a domain. That's probably not the place we want to look, because if we scroll over further, we'll see there's a link, right? So if I have a domain that's potentially involved in some sort of phishing, some sort of malicious activity, it's probably going to be a link that is the interesting part of that activity. So we can use KQL and we can ask the question, where do we see mobile.io? Has our company been targeted using this malicious domain? So we can write a query where link has mobile.io. And we have one hit. So this is on January 5th, 2022. We have James Wilder at pharmasupplies.org, sent an email to mabrown@involvelabs.com. The subject line seems a little weird, right? New help desk procedures, read now. So let's keep that in mind as we continue our investigation here. And then we have our link. So this link is mobile.io, and then we have a fairly long URL here. And ultimately, I notice here that it ends with Involve Labs research tool.7z. That's a 7-zip file. So a couple of interesting things here that we pointed out along the way. The sender, pharmasupplies.org. That's kind of strange. Let's come back to that later. But we have the subject that seems sort of urgent. The capitalization looks a little off. And then also the malicious link. So Simeon, where would we go next from here?
Yeah, Greg, one of the things that you mentioned before is learning how to ask the right question, right? So in this case, I was tipped about a malicious domain. I saw that someone in my organization received an email containing that domain and the link with a very funny looking file name, right? That may have been targeted towards my organization because it has, Involved Labs name in it. And so the question I want to ask is, okay, well, what do I want to know next, right? And usually from my perspective, right, if I want to think about protecting my organization from whatever this threat is, I want to figure out, what that file is maybe, and whether or not someone clicked it. So Greg, right, using my data here, right, I want to try to figure out how can I determine if someone clicked the link that was sent to them in email. And I'm going to go on the left side. We see a list of tables that are underneath our security logs, right? We have authentication events, email, employees, inbound. Outbound browsing might suggest that it's information about websites, about traffic that's going from the inside to the outside of our organization. So whenever someone clicks a link, information might be logged there.
Right. And if we forgot that, right, it's been a while since we looked at all these data sets. The packet at the very beginning, it's going to give us an overview of all the different data sets we have access to. So we can always go back to the packet and remind ourselves that outbound browsing records browsing activity from within the company network out to the internet. So I agree, Simeon, that's the next place we should look.
Exactly. And like Greg said, right, whenever we're in a place where we have a new data set and we don't know what to do with it, we're going to do a take 10 to see what's inside of that table. So we're going to do a take 10 on the outbound browsing table. And just like Greg saw, right, it's information about, okay, this IP, which represents someone inside of our network, some employee in our company, is browsing out to this URL, which is outside of our organization, right? Some website on the internet. And so the question one to figure out here is, did anyone or did the user who received the link with mobile.io actually click on that link? And there's really two ways we can do this, right? One way is we can see if anyone has clicked on mobile.io, and the other way is we can check to see if that particular user clicked on mobile.io. In this case, we're just going to cheat and we're just going to ask if anyone has gone to that website. So let's say, where URL has mobile.io. And we do see that, whoever this user is, someone did click on a link with mobile.io, and the link appears to be identical to the link that we saw that was delivered in email. We can also confirm whether or not it was the same user that clicked on the link by going through the employee table. So the employee table is going to have information about each user in the organization and what their IP address are, what their email address is. So if we go back to where link has mobile.io, the email where link has mobile.io, we can see that James Wilder is the person, M.A. Brown at involvelabs.com is the person who received that email. Well, in our employee table, we can ask ourselves, well, what is M.A. Brown's IP address? We can say where employee email address is equal to mbrown at involvelabs.com. Once we run that, we can see that the IP address is 192.168.1.129, right? And that should also correspond to the IP that we see browsing out to mobile.io inside of our outbound browsing table.
And it does, right? So what do we know from our investigation so far? We started with a partner tip. They said, hey, there's this suspicious domain. We think it may be affiliated with some email-based threat activity. So we took that tipped domain, we went into our email data, and we asked the question, has anyone at Involve Labs, has anyone at our company been targeted using this domain? We found that the answer was yes. There was one employee. And so the next logical question was, okay, did the person click the link, right? We need to assess how far did this attack go? And so we looked in outbound browsing. We checked to see if anyone in the company browsed to mobile.io. We found one hit. We noticed that the URL was the same. And then we were able to confirm that the person who clicked the link was in fact M.A. Brown, the person who received the email. All right, so we can take this a little further. We noted earlier that this URL has this suspicious looking file name, right? Involve Labs research tool.7zip. So like Simeon said, this appears to be targeted specifically to our organization. It actually has Involve Labs in the file name, which definitely sets off some alarm bells and makes us want to dig into this further. So if we know that M.A. Brown has downloaded or clicked the link, let's see if we can find whether the file was actually downloaded to their system, to their computer. And so we have a couple of places. Again, if you don't remember what the data sets do, check the packet. Where can we go to look for employee device-based activity. Well, we have two tables here that mention employees' devices. There's file creation events and process events. And since we're looking here for some specific file being downloaded, we're going to start in file creation events. And so, as there almost always is in threat analysis, there's a couple of different ways we could start to answer this question. So we have a file name. We got that from our URL. So we could look for this specific file name anywhere in the company. Does anyone in the company have a file named involve labs research tool.7zip on their system? We could also go, because we now know there's the specific employee who clicked the link, we could go look at their system specifically and see if we can find the related activity. So let's take that approach. In the employees table, we have this host name column. This is going to tell us the name of M.A. Brown's computer. So we can grab the host name value. We're going to go into our file creation events, do a take 10, make sure we know what we're working with here. And we see there's also a host name column here. So let's retrieve all of the file creation events for M.A. Brown's system. And it tells us we have 6 records. And if we look at the file path and file name columns, we'll see first on the list here is involve labs research tool.7zip. And if you remember, the email was received around 1:05 at 10:13. The click was 1:05 at 10:19. And then the file showed up at the same time. So now we're building out this picture. We know they received the email, they clicked the link, and they downloaded the file. So Simeon, how do we find out what happened next?
Yeah, so the good question is, okay, the user received an email, they clicked the link, they downloaded the file, but what did the file actually do? A good technique sometimes when we're doing cybersecurity analysis is do timeline analysis. What happened around the time of the malicious activity? Greg took a brilliant approach of actually looking at the user's box. So since we're looking at the user's machine specifically, we can look around the time that the file was downloaded and see what else happened or if anything else suspicious happened around the time of the activity. So we see that at, on January 5th at 10:19 a.m., the user downloaded, if you scroll to the right a little bit, the user downloaded that involved labs research tool. But then right after that, we see that there was a file that was written to disk just a couple seconds, maybe a minute later. Just a couple seconds later, it's an update.dll in Microsoft Programs application, right? So this seems like kind of an unusual file. We don't necessarily know if it's malicious. One thing we might do, Greg, right, if we don't know anything about a file, is we might search in VirusTotal to see if that file is legit or malicious. So let's take that hash, and Greg's going to open up a new tab, and he's going to go to VirusTotal, and he's going to check whether or not the file is malicious or legit. So he's going to click on the search button, and he's going to pop that hash right in there. We're going to see if it's something that we actually know about. And alas, right, VirusTotal is a collection of files, right, that different security vendors, scan and it tells whether or not it's legit and malicious. In this case, right, the file that was dropped right after the attachment or the payload that was sent, the 7-zip that was sent to the user is assigned as malicious by the actor. In this case, right, this is an iCard test string. It's not actual malware, but it's something that we demoed for the instance. But as a user, that you found something malicious, so you might determine, okay, well, user received a file, clicked on it, downloaded it, and then it dropped right afterwards some malicious file on the user's box. All right, so once a file is dropped on disk, right, we might wonder, okay, what was the purpose of dropping that file and what might it be used to do? Greg, if you go back to the packet, right, again, we have that table. That diagram that shows us what the different tables are and what we can find out. We have 2 tables that show us information about devices. One of them is file creation, the other one is process events. The process events table shows us processes created on the employee's device, right? So how are files actually used? Let's go look at that table, and we'll also take the same approach of looking at the victim's host name, right? And we'll talk about time analysis, what happened around the time of the activity. So Greg's done the take 10 on the process. events table to see what kind of information we have. Process events is or host name is one that corresponds again with the host name of the employee. So we're going to look for everything that happens on that user's machine. And we see that around 1:05 on that same date that the activity happened, we see that the file update.dll that was malicious on VirusTotal actually spawned two processes. The first one is a whoami command, which is typical what a piece of malware or an adversary might run a command to find out more information about what's going on in the system. And the second one is a scheduled task command, right? So we see a scheduled task being run to establish persistence on the user's machine. So at this point, we know that we have a compromised machine on the user's box. That we may want to go out and reach out to the user and grab their laptop, have it wiped, and make sure that there's no other impact to the company. So we know that at this point, right, there was something tipped to us in open source about a malicious domain, and we see that it was used to target our organization, and we see that now there's actual impact to the organization, which may spawn, right, some type of incident response, may spawn some type of incident response process depending on our organization.
Absolutely. So to summarize, like Simeon said, we were able through KC7 to go end to end, right? The game's called KC7 based on the Lockheed Martin cyber kill chain. KC7 is the final stage of that kill chain, actions on objectives. And so in the course of our investigation, we were able to go from the start of the kill chain all the way to the end. We didn't get quite to KC1 in this demo, but there is evidence of reconnaissance in this data if you go looking for it. So that's a good transition into sort of another aspect of the game. What we showed here was an investigation about one particular incident, right? We looked at, in this case, one compromised user. But another thing that we can do in KC7 is take a more actor-centric approach. So if we go back here to our initial lead, looking at email data, there's a couple of things here that maybe are unique to the actor and something that we can use to learn more about this adversary and find activity impacting our organization that's related to that actor. So let's take this sender email, for example, James Wilder at pharmasupplies.org. So if we know that the actor used this email to send a link to this malicious file, maybe they use that email again. So we can try, instead of looking for a known bad link, let's try where sender is this email. So now we've gone from one targeted user to two. And you may ask, okay, why didn't we find that the first time? Well, if we look at the link column, the first email uses our known domain mobile.io, and the second one uses a different domain that we did not have tipped to us. So that was scanverify.com.
And Greg,
so
what else can we pivot on, Greg?
Yeah, it's a great question. So we have more options here, right? We could try this subject line. Maybe this is something that's repeatable, where the subject is this. Oh, wow. Okay, now we have 7 results. And if we scroll over again, we see more domains, updatesoftware.com, mobile-install.io. And then we had another subject line we could try to pivot on from our results before, right? Also, if we go back to our initial investigation query here, we have this file name, right? And we were able to find that in host data. So if we go to our file creation events, we could see if this file shows up anywhere else in the network. Turns out it does. So now we're sort of at the end of the kill chain, the end of the attack. If we wanted to figure out what happened here, we could work backwards, right? So we have a host name. We could figure out who that host name belongs to, figure out what their email address is, and then try to identify how they were targeted. There's a whole other aspect here that we've modeled that is passive DNS data. So passive DNS data allows us to explore the infrastructure that's used, the domains and the IPs. So if we take our mobile.io domain, we go into passive DNS data, we can look to see what IP address is associated with our bad domain. And it turns out there's actually several. So I can use a compound query using let statements, and this is all explained in the packet, but I could take all these IPs that are related to my known bad domain, and then I can pivot back into passive DNS data and try to see what other domains might be related. Where IP in IPs, and let's see how many domains we have now. So we started with one domain, and now we have 3. We found 2 new ones. So we could even do this again, right? We could do this over and over and start to blow up this cluster and understand more about this actor. I'll show one more. We'll go one more layer deep just for fun. What did I do wrong here? There we go. So now we're up to 8 IPs. So we could pivot on those again and try to find more domains. We could be here all day if we keep doing this, but you can see there's a lot of data to explore. There's a lot of adversary activity that we wouldn't find if we stopped and assumed that the only indicator here is mobile.io.
That's a great explanation, Greg. So let's talk a little bit about our process and what does this actually look like when we have an event with students. So generally, we recommend 3 to 5 hours with students. The more time that you have and the more time students can spend looking at the data, the better. However, it can get a little bit long, and it's not always possible to get the full amount of time. Generally, we have run this event with students who have no experience in cybersecurity, and not just students, right? We've done this event with students from 8th grade all the way up to security executives at tech companies, right? And everyone in between, including cybersecurity industry professionals, threat intelligence experts. And we've generally found that people are able to get something out of the game that they didn't know before, or practice skills that they had before, but they weren't able to see the big picture of everything. In the beginning, we'll generally do a more interactive session with students to get them excited about cybersecurity. So we like to talk about, not just the what, but the why of cybersecurity. So why do people hack? What is in it for them? Who are the different actors around the world, right? Hacktivists, nation states, cybercrime. Why do they hack, and what is in it for them, and why would they expend so much effort and money? And we generally found that helps students connect with the messaging and connect and put themselves in the mindset of the attackers. Then we move over to helping them set up the different tools they need to be successful. So helping them get access to the Azure Data Explorer clusters, helping them get access to the KC7 guide. And in some instances, we actually use a scoreboard, which we can give you a link to that below, that actually allows them to answer, to put in the answers to the questions that we provided, so they can compete with other students in the game. After that, we actually walk them through the KQL 101, get them comfortable, and then we set them loose answering the questions by introducing the cybersecurity actors. Generally, the training guide will have everything you need to walk students through end to end with a guide. So all you have to do really is to give students access to the data and hand them the training guide, and most will be able to figure out what to do from there. You may have to interject a couple of times to help with some more sophisticated topics, or if they get frustrated or if they get stuck. But generally, the training guide will be able to walk students through from end to end, how they can use the KC7 data in Azure Data Explorer to learn those analysis skills and develop those on their own.
Right. And a couple of things we always notice. So when we talk to students, we encourage them to work together. We always say cybersecurity is a team sport. And that's true. Cybersecurity professionals at different companies work together regularly, because ultimately we all benefit when the world is more secure. And so we encourage students to work together. like Simeon said, there is a competitive aspect as well. In some events, we use the scoreboard system because that helps drive engagement. Students like the idea of earning points and trying to beat their peers. But they work in teams generally, and they work together to answer these questions. So if they get stuck and if the training packet doesn't sufficiently explain something, there's always an opportunity for them to get help from their peers before needing help from an event facilitator. The other thing I'll say, so we talked a lot about the student experience, but like Simeon mentioned, we've actually run this event with executives at tech companies. And so for those folks who are looking to use KC7, but maybe already know the basics of cybersecurity, they understand the difference between hacktivists and nation state. They understand how hackers hack. So instead of starting those events with cybersecurity 101, we typically dive straight into some of the more nuanced topics around threat intelligence. So we'll talk about the diamond model, the kill chain, MITRE ATT&CK, some of the tools and frameworks we use for threat intelligence analysis. We'll talk about activity clustering. We'll get into some of the nuance of misattribution. So regardless of the experience level of the audience, there's lots of content in KC7, and we can really scale the experience so that everyone can get something out of it.
So we thank you for taking the time to watch this demo. If you have any questions, have any feedback, want to support us, you can go follow us on Twitter at KC7 Cyber. Give us your feedback, interact with us. We have our GitHub page on github.com/kkneomis/KC7, and we'll drop that in the link below. Thank you so much for following along with us, and we look forward to engaging with you and helping more students and more people around the world get those critical cybersecurity skills that they need to be successful, through this realistic data set. Bye-bye.